And hello, everyone. I'm a developer advocate at Lightbend, and welcome to this talk with this somewhat difficult title to say, From Stateless-Serverful to Stateful-Serverless. And I'm going to use a little bit different way to do my presentation, but most of my talk will be in code, but I'm using a little bit something different here. So the beginning of the talk is really kind of focusing on state and also state and how it's managed in a stateless way and then how it's managed in a stateful way. By far the more common way that we do things, I know for me, I've had a long career building backend systems, and the primary pattern that I've used is stateless. But now I've been doing a lot of things with stateful systems, and that's why I wanted to talk about this. So the interesting thing, though, is serverless is becoming a big thing, and one of the things we're hearing it less, but one of the things we often hear is that with serverless, of course, there are servers, and of course we know that. Developers, architects, our IT management, those types of things. We understand that, but I think it's more for other people. But the idea is that even though you're saying serverless, there's still servers. But the thing with stateless, of course, there is state. And what I mean by that is that state is about a thing. So there's, say you have a classic shopping cart application. Well, state is, say, the current state of a given customer's shopping cart as they're interacting with that shopping cart. They're adding items to it. They're making changes to those items. Maybe they're removing items, and then ultimately, hopefully, they're going to hit the buy button. But that order is a thing of state. The stateless, though, is actually how we manage things. So one way to think about our backend apps is that they're state management systems. These backend systems receive requests to perform some kind of an operation. I like the terminology where the application receives commands, like add an item to a shopping cart. That's a command. Remove an item from a shopping cart. Those are state changing operations. So these requests comes in, they're treated as commands, and we're manipulating the data in our systems. So what's the difference between stateless and stateful, and how do we what's the difference in how we do the processing? So here hopefully this comes through for you. I'm going to do a little simulation. This is why I wanted to use this tool. Is that, say this is a stateless scalable app. And one of the major features of stateless is that it is scalable. The typical stateless, say Java type of backend system, you can have one instance, and if you need more computing capacity, you can handle more instances. So these little dots that are flowing out of this server just represent individual units of state, state objects. And these objects exist for a short time while we're manipulating the state. We retrieve the state from a database, we make some kind of change to it, and then we put the state back in the database, and the object goes away. So this is kind of the idea here. So the thing I want to kind of simulate, though, is, say we have a spike in traffic. Now the load on this one node is getting heavy. So the beauty of the stateless system is that, oops, I went too far. Here we go. Is that you can scale. So you can easily scale. And this is a fundamental feature of stateless, in that each node that's processing those requests, those commands, only has state for a very short time while it's making some kind of a state changing operation. And then the state is thrown away. So this, my shopping cart could maybe first be handled by a request into the node 2 here, the center node. And then my next request could just as easily go into node 1 or node 3. And that's by design in the stateless type of application. This is the beauty of stateless. It's simple, and it's easily scaled. So what I want to show you though is down at a little bit more kind of in the code level is what kind of the mechanics uh, of a stateless flow. So first off is that we have, say, some kind of request coming in to perform some kind of an operation. And as I mentioned, I think of commands or requests as commands to perform an operation. So that triggers the retrieval of the state from the database. And I like to use the terminology when I'm talking about stateful and stateless is cold state and hot state. So I think about data in a database as cold state, it's frozen state, it's there, it's in cold storage. You don't change the state in the database, you change it in a hot state space, in our compute space. So we retrieve the state, and then now we have the state, kind of representing it as this little circle here, and we can perform our state changing operation. Oops, I went too far. And then we, once the state changing operation is completed, then we write the state changes back to the database, back to cold storage, and then we send a response back. So the sequence here is that a request comes in, we retrieve the state from the database, we perform our changes, write those state changes back, and then send back a response. And it just repeats over and over and over again. So that's a stateless processing flow. If we go to a stateful processing flow, it's very similar, but there is a very distinct difference in that, say, the first request comes in for, say, my shopping cart. I want to add an item to the shopping cart. So the backend system gets the request. So just like with the stateless flow, everything's still the same. Then the state is retrieved from the database, from cold storage, because the state's not hot right now. It's not in memory. And then we perform our, process the command and alter the state. And then, of course, we send back the changes to the state back and, to safely store it back into the database. And then we send the response. But so far, nothing's changed from a stateless flow. But here's where the change comes in. Now the next command comes in. The next request comes in. We do not have to retrieve the state from the database because the state is already hot in memory. So it's like what it actually is you can think of it as there's an object. It's resident in memory somewhere on some machine, and every single request that comes in for that that particular state, like my shopping cart, there's an object. Your shopping cart, there's another object. Somebody else's shopping cart, there's another object. Those objects they remain in memory somewhere in a cluster of machines. That's the trick to this. So what we're saving here is we're not having to do the retrieval from code state anymore, which, this is where we can get a bit of an optimization if you can do this. So the flow here is that command comes in, the state's already there, perform the operation, write the changes back, send it back the response. Another command comes in, we don't have to hit the database, make the changes, write the response back. So like I said, the savings here is that we read the state from cold storage from the database once, and we keep it hot in memory as long as possible. And there's an optimization in that we're not having to hit the database as hard, because I don't know about you guys, but my experience has been that often when I have a performance issue with some kind of a back-end application, it's normally database related, that we're pushing the database to some kind of a limit or something like that, and the load on the database is at a point where the entire application is slowing down. So no matter how much I can scale the compute side, I may not be able to as easily scale the database side. The scaling of the database capacity is completely independent of the scaling of the application side. So this is the big difference between stateless and stateful. Stateless is great. Like I say, it's very mature. We got great tools for it, and it works, and we know how to do it. If you're a Java developer, odds are really high that this is the kinds of things that you do. but stateful is now becoming a possibility as well. So as I mentioned, you get the reduction in I/O, and the reduction in I/O is because, and this is the trick, is that there is a single writer, for each particular instance of state. Again, it is very much there's an object or a set of objects that are instantiated for a particular single instance of state, and all the state changes that occur have to be routed to that object, regardless of where it is in the compute space, in a cluster of machines. When you can solve that problem, then you can build stateful systems. Another interesting thing is that there's this kind of inversion of state. And this was a real aha moment for me when I started building stateful applications, where I realized that the database is kind of a secondary store of my state. The real state, the actual up to the moment, right now, what is the current state of my shopping cart is in memory somewhere. So there's this kind of inversion that occurs. And with a stateless system, there could be two instances processing commands for the same state. So now what we have to do there is that the database is the concurrency control, locking and things like that are built into the database, so that we, multiple state changes that occur in the compute space are work together nicely, and that has to be coordinated through some kind of locking control, concurrency control, transaction control within the database itself, which puts more burden of responsibility for computing these things and handling the processing of that on the database. In this stateful type of situation, the concurrency isolation happens in the compute side. So enough slides. I want to show you an example of how this is done. And this is Akka Serverless. So Akka Serverless, we actually announced general availability. We're in beta for some months, and we just announced general availability this week. And what Akka Serverless is a serverless platform for building stateful types of applications. So the example I'm going to show you here is doing event sourcing with a serverless implementation using Akka Serverless. Now, if you're familiar with Akka, and if you're familiar with Lightbend is a company behind Scala. So we're big in Scala, but Akka itself is a very large tool set, and historically, though, it's only been for Java or Scala developers. With Akka Serverless, it's polyglot. So already now we have Java and Scala, of course, but we have things like JavaScript and TypeScript and Python and Kotlin, and I think people are working on Go and many other languages, all being able to build serverless services using what's called Akka Serverless, but now in a much broader language, number of language category. We're definitely not constrained to just Java or Scala anymore. So the way it works in Akka Serverless, when you set up something like an event sourcing service, it kind of starts with a contract first. And what's done here, let me go to the right project, is we start with protobuf definitions, they're called. These are Google protobufs. And there's kind of two things to define. One is you define the API of the service. What does a service look like on the outside? So in Google protobuf, it's the syntax is set up to do that. It's pretty simple. You define a service, like I've defined a cart service here, and then you define the different types of operations that, what this API looks like. So add item takes in an add line item request, and it returns a empty, this Google protobuf empty, just to acknowledge that I got the add line item. This next part here is just defining the path. If you're hitting this service via, so like a HTTP RESTful request, it would, you define the path here. And then I define, things like change item and remove item and so on. You basically define your API using this protobuf file. The other protobuf file is it defines what the service looks like on the inside. And we're defining things like here, like this is an event source entity, which is doing event sourcing. And with event sourcing, there are events. So the idea is that when, say, you get a request to add an item to a shopping cart with event sourcing, you emit from that operation a item added event. So I'm defining item added here in this protobuf file. So the syntax of this is pretty straightforward. Now, the reason for doing this, though, is that there's code generation built in. So these protobuf files are used to generate the service, basically. Not everything, of course, because we're not out of a job, but it generates a lot of code for us. And what it does then is the main thing that it generates is this the implementation of this particular service component, it's called. So you can see, here's my shopping cart class, and it extends a base class, this abstract shopping cart. Now, this abstract shopping cart, the source for this is in the target directory, and it's generated on every compile. But this class is generated once. The way this works is if the class source file doesn't exist, when you run a compile, it will generate it for you, and it stubs it out. What it does is it kind of stubs out this class, and it stubs out all the API methods. So like here's add item, the add item, change item, remove item. So this all got generated for me once, but then once it's generated, then I go in and I start writing my code. So that's what I've done here. I've started with this initial definition of the service that I got from the definition that I've defined in my protofiles. What does the API look like? What are the events and those types of things? And then I come into this class and I start implementing my business logic. So the way I did it, and this is my personal style for how I'm writing these services, and I just so it's not like you have to do it this way. What I have to do, though, is I have to return an effect empty after I process the add item request. And you can see that there's two parameters passed into this method. One is the command, the add line item command. The other one is the state, which is the current state of the shopping cart. So the Akka serverless we often refer to it as databaseless, which means that of course there is a database, but I don't have to set up a database. You don't have to set up a database. We don't have to deal with all that. There is persistence, it's built in, but it's kind of abstract. All I'm doing here is defining this service. Persistence is set up for me by the serverless platform. So, and part of that is then is that, say this is adding the second item to the shopping cart. This current state object is going to contain the current shopping cart. Now, if it's hot in memory or if it had to retrieve it from the database, that's not my concern. That's as a developer. That's not your concern as a developer. That's being handled by the platform. So all I have to do here is, I'm past whatever the current state is of this object, my state. What's the command? And I'm going to process it. So that this flow here that again, this is my personal style. I say reject is a method and its current state command, or else handle the current state command. And you might already guess, but reject is doing validation. So I'm just validating, given the current state and the command, is it okay to process this command? Is everything okay? And I'll show you what the validation looks like in a minute. But you can also guess that this reject method returns an optional because of the or else here. So I kind of struggle with this when I first implemented, do I say validate or else handle? And validate just implies something that I need to do, whereas reject kind of implies if there's something wrong, I'm going to reject it, or else I'm going to handle it. So, and again, this is my style. And then there's a handle method. So if everything's fine, the command is okay for the current state, I'm going to invoke the handle method. So I'll show you an implementation of this reject method. So I'm just doing basic validation here. If I'm looking at things like, is the cart checked out or deleted? Is the customer ID blank? Is the product ID blank? Is quantity less than 0? If anything's wrong here, I'm going to return, this response. Effects error, customer ID is required. If everything's okay, I'm going to return an empty, which means I'll go back to the and the or else, and we'll do the handle method. So in the handle method, it's also pretty straightforward. Here, what the process is to create an event. So I'm building a item added object basically, and these are generated classes. So this line item and item added, these are generated classes based off of my protobuf definition. So I didn't have to write these things. And it uses a builder pattern. So it's kind of like a plain old Java object, but it's kind of based on this builder pattern. So I'd say I want a new instance of this object. That gives me setters like set product ID, name, quantity, and do a build. So now I have a line item. And then I can actually build the event, which is adding a few more fields like the card ID and the customer ID, and then adding the line item and build. And then down here, there's return effects and then emit event. So this is where the only thing I have to do to say I want to persist this event. So this is where the write will be triggered. That's it. I didn't have any database connection here. I didn't set up any schemas. I didn't deal with any URLs or passwords or anything. All that's part of the platform. So I had my protofiles. I start writing the business logic in my code, and off we go. So I'm emitting the event, and then I'm sending back the empty response. So I've created the event. So if you look, then processing each of these different types of commands, like change line item, it's the same thing. It's just overloaded methods. For reject is for change line item quantity versus add line item, and so on. So I just kind of copy paste that. And then another set of methods that I have to implement, you can see that it's overridden. The code generator gave me these methods, is I need to deal with the event. So when the event has been persisted, this method will be invoked, like item added. And then here, all what I need to do is I'm changing the state of the state object, basically. So I'm just using kind of a helper class here. It's an inner class. I call it shopping cart, and it's got this static method where I take in the current state, and then I handle the event, and then I take my kind of helper method and give back the altered state. So this is kind of this flow here. So if I show you let's show you the handle the event. In the event, what this helper class does is it has I took the shopping cart line items and I just threw them into a nice hash map, because I need to manipulate those things, and for me it was easier to do it in pure Java versus those builders that come with the generated code. So I can do things like if I'm adding an item to an item that already exists in the cart, the business rule is go ahead and just add the new quantity to the current quantity, or else if it's absent, compute if absent, which is a nice map method. Then I'll add a new item, and then I build the state, and I'll set up create the new state, and that's it. So the flow is pretty straightforward. So again, these event handlers methods that I have to implement all pretty much follow the same pattern and flow here. So that's it. It's kind of going through, and I set up this pattern reject or handle. I set up this pattern for my event handlers, and then I implement the code, like all the different reject methods, reject for add item, reject for change item, and so on. Really pretty straightforward. And then I get into handling the commands to create the events. So there's a whole series of these overloaded handle methods for doing that. And then when I'm doing a get, I need to build a response. So this toAPI is taking the current state, the kind of the internal representation of state, and building an API response of the state. That's all I'm doing here. And then here's the this helper class, this shopping cart class. Again, this is my code. You don't have to write it this way if you were to use like a serverless. If you look at the documentation in the various different languages, you'll see things are done differently. But I've been writing now services like this over and over, and this pattern kind of emerged for me as a developer that I kind of like right now. And it's constantly evolving anyways. You know how it is when we're writing code. You write it the first time, you like it, but then you look at it a week later and go, oh man, why did I do it that way? I need to fix this. So that's it. So next then there's an easy way to create the project here and with a Maven archetype. And I've done videos showing this, but basically you create a Maven archetype to kind of give you a basic template project. One of the nice things is it gives you a fully populated POM file with plugins for doing lots of things. The big one being you can do a deploy. So I can deploy this service to Serverless in a full running environment where the databases database will be set up, all these backend tables, whatever that I need for my service will be set up, and it'll deploy it and it's ready to go. So I just do a Maven deploy, and the only thing I really had to change here is some information about the Docker. It's going to build a Docker image, and that Docker image is going to be deployed to the serverless environment. So I have McKee H3 is my username in Docker Hub. So then it's deployed. So if I go to, no, I don't want to do that. Getting the echo. This is the console in Serverless. And I've deployed actually two services. One's called Shopping Cart and one's called Shopping Cart Pub, because this pub is demonstrating doing like a Google Pub sub between something where the shopping cart service is set up to consume incoming commands from a topic versus taking commands in from like HTTP or gRPC. So this pub service is a simple little implementation where I implemented that. But in the shopping cart service, you can kind of browse around. But the main thing I wanted to show you here is in the Service Explorer, you can see all of our methods here, and add item, remove item, and so on. And this service, the reason I call it advanced, there's quite a bit of code in this advanced implementation in this project. And I'll give you the URLs to the GitHub repos for this at the end of the talk. But one of the cool things that I really like about in this console is that we can test the service immediately once it's deployed from the CLI using gRP curl, or because I implemented the curl command, the paths in my API protobuf definition I showed you back a few minutes ago, it will give me the syntax for the curl commands. And this is pretty handy because especially for something like add item, where there's lots of fields, the syntax, setting up the syntax for, say, a curl command can be a bit tedious, but it does it all for us. So, but there is a nice feature. I'm using VS Code, and I've been long time user of IntelliJ. Love IntelliJ, but I about a year ago or so I switched over to VS Code just to try something different, and I'm really happy with it. It's a pretty cool tool, and I just love it even more because there's this one feature that's called REST Client. So what I did was, what you can do with REST Client is you can make HTTP requests. You can create a little file that either does like pure HTTP requests or like these curl commands, and you can just use this as a way to quickly, instead of copy paste and from into a CLI, I can use this REST client. Now this is an extension on VS Code, but it's pretty cool. So what I did then is another nice feature. It has variables. So it's got this URL prefix, and I can set for the, because this is the host name for this service. I'll go back to the console in a moment to show you that. But then and this is just what I set up. I set up, just variables for customer ID and so on. So I can tweak these values and play with these different commands. So I copied and pasted all the curl commands from the console into this file. So now I can do a add item, change item. Yeah, I can do the get cart. And so based on my current values, I can see if I've got any data out there. And I think I do because I did it before. There we go. So I've created a shopping cart for customer 1. And right now it's got 3 items in the cart. Product 1, product 2, product 3. So, and I'm hitting this service live. Right, it's running in this production environment, and I, just wrote the code, implement the business logic. That's all I had to do. Deploy it. The service sets up in a few minutes. The first time it's up and running, ready to go, and then I start testing it out. Now, of course, I can write unit tests and integration tests, but this is just kind of writing the code and just going straight live. So, so adding, say, another cart, like cart 2, I can just do this, and I should be able to do send a request, and I get back the empty response. And if I do the get, we see that new cart. Now, another thing I want to show you in the last few minutes that I've got here is event sourcing. Typically, you hear CQRS and event sourcing, or event sourcing is CQRS. So built into this is the ability to do CQRS. And I've already implemented that. They're called views in microservices. And what the view I created here as an example is I can query all the orders for a given customer. So for customer 1, I've got all the orders, or the order for cart 1 here, the first one. And I've got the order that I just added for cart 2. So that's coming from a view. And setting up the view is very similar process in that there's another protobuf for that. Where's my protobufs? Protobuf view. Oh, I'm in Java here. Oh, sorry, I'm down in Target. I'm lost in my browser. Here's a view. So it's just another definition. And here, what I had to do to set up a view, you can see it's a service type view is defined. So I had to define RPCs to handle each of the different events. So it's eventing in. I'm saying, where is my data coming from? It's coming from the event journal that was created by the other service. And then I'm performing this update. So the thing I want to show you, though, is here. You define the characteristics of the view basically using kind of a SQL syntax. So I'm saying select all as orders from this view table where the customer ID equals the customer ID. That's all I have to do. And then again, this will set up the CQRS part, the query part of CQRS, command query responsibility segregation. So my commands are handled in one part, and then the view is, of course, is segregated from that and is handled in another part. So this is what I had to do. And a bit of code to do that for the handling each of the different updates, but it's really pretty straightforward. Implementing the logic. You can see it's very similar pattern to what I showed you in the event sourcing process, the command side versus the query side. So that gives me the the ability to do these kinds of queries, handle the CQRS part, where I can send these requests and test it. Is my view working the way I want it to? If it doesn't work right, I can tweak whatever code, I can fix it, redeploy, try it out, and off we go. So the big thing here is that I showed you this code, but there's there's no database that I did. Let me go back to the get this cleaned up. Give me a moment. Just get this cleaned up. Here we go. So yeah, so this event source entity, as it's called, is implemented, in Java. No annotations, no serialization, no database that I had to set up, no connection pool, no schemas. All that's this is kind of what serverless does. So it lets me focus really pretty much on, here's your class developer, go fill out the business logic, let's deploy it, and let's see if it works. And if it works, it's ready. It's ready for production. So this sample service that I showed you, there's two projects. There's one called shopping cart service, and there's one called shopping cart pub service. I showed you the code for the event sourced entity, but there's another one, and the code's in there as well that I didn't show you in this talk. Is for it's called a value entity, or I like it, key value as a service versus event sourcing as a service, as a serverless service. So these are components. So the way things work in Akka serverless is you define projects. Projects contain services. Services contain components. So components are things like in components in Java, components are classes. So this event source entity is the class I just showed you. It handles the incoming gRPC or REST requests, and it processes them, and it persists its changes out to some kind of event journal. If it's key value, it has basically the same API. It's a shopping cart example, same shopping cart API, but now the internals, it's doing what's called, we're just kind of doing a CRUD-like operation. We're not emitting events. We're just updating the state and persisting the state, so the state goes into a state store. The other components, so in order to do, say, pub sub, there's defined code for doing that. This is really simple. There's almost no code involved at all to do this. These are called actions. And these actions are stateless functions. So I've got one action that is set up to, it has an API to say, for add item, change item, remove item, check out, those types of things. And it takes those incoming commands and it just pushes them into a topic. And there's another action that picks up those commands, the message of the topic, and then forwards them to the API of the event source entity. So it's a demonstration of kind of a asynchronous flow between two services. Where via some kind of a message bus like Google Pub. So Kafka's available as well, of course. And then for the view, the CQRS part, you can easily define these views. And again, the logic that you have to implement is pretty, like what does the view data need to look like? That's really all you really need to implement is that. So it's these update methods. The update methods receive the events if it's an event source entity, or the update methods receive the state if it's getting data from a key value. But it's taking that data and then it's putting it in whatever format you want to put into your queryable side, and then that data gets persisted. But again, on the view side, there's no database that we have to hook up to. There's no connection pool, no tables to set up, none of that. So again, there's 2 projects here, all the sample codes in it. These are the links to the projects. So it's GitHub. McKee H3 is my GitHub user. And the first project, shopping cart Java Akka serverless. And the second part is shopping cart pub Java Akka serverless. If you just go to my my user McKee H3, you can find them there. Java, you can download them. You could set up a free account, a trial account with Akka serverless, so it doesn't cost you anything. If you want to actually try these out and push them out to a live serverless environment and make some data, play with it. So that's about it. Like I said, to me, Akka serverless is new. I mean, again, if you know about us at Lightbend, I know we're not huge, but Akka has been around for 11 years now. I fell in love with Akka back in around 2013 when I was working at in a HP Hewlett-Packard in enterprise IT, and I started building actor-based systems using Akka, and I just fell in love with that, and that's what was my first taste of stateful systems, things like that. But Akka serverless takes things to a whole new level where, like, I've been doing a lot of work over the last couple of years before serverless using Kubernetes, and I love Kubernetes, but there's still a fair amount of work. I still have to set up a database. I still have to deal with Kubernetes. I have to deal with all that YAML stuff. I have to deal with secrets and this and that. There's a lot of details even there to set up a nice Kubernetes environment. I know it's way better than it was before, but this just takes things to a whole new level, this serverless stuff. And for me, as a developer, as a developer advocate, I write demos, and I show people how to do things. And to set up these demos where I have a fully functioning application where I've got data and it's working, and it's like I can write a new one like in a morning or in a day, it's pretty cool. So it's not so much what I think I've been saying. The interesting things, it's not so much what you have to do something like this using something in serverless, and like with Akka serverless, it's what you don't have to do. It's amazing all the things that you don't have to do to actually get things working. The other thing I'd like to say is that Akka serverless is new. So anybody that starts up and gets serious with us, you're kind of a founding member, and you have a major vote in the evolution of how things evolve with Akka serverless. There's a lot of functionality already in there, very exciting. But I think, and I'm not quiet about say I really want these kinds of features and voices from real people. I'm not a real person because I work for Lightbend. For real people like you, if you start using Akka serverless and you want a feature, today's the day. Now is the time to start doing that, because you'll definitely get a lot of attention. We're really hungry to see this get used and get feedback. What do you like? What you don't like? And so on. So, thank you very much. I think I'll be ready for some Q&A.
Thank you, Hugh.